So today we'll be using trigonometry to solve some applied problems. And so right triangle trigonometry is useful in measuring heights or distances that would be otherwise difficult to measure by ordinary means. Um, so when we do this, what we need to pay attention to is what is the information that we're given, and that's going to help us determine which of the trig functions that we want to use to solve a particular problem. Okay, so let's look at this example. A surveyor can measure the width of a river by setting up a transit, okay, at point C on one side of the river and taking a siding of point A on the other side. After turning through an angle of 90 degrees, the surveyor walks a distance of 200 meters to point B. And using the transit at B, the angle theta is measured to be 20 degrees. And we want to find the width of the river rounded to the nearest meter. So we can see here that if this is our angle right here, okay, then B is the opposite side and A is the adjacent side. So we're dealing with opposite and adjacent. So we know that the tangent of 20 is equal to the opposite side, which is B, over the adjacent side, which is A, or so we know this is tangent of 20 degrees is equal to B over 200. And now we can solve this equation for B. So we'll multiply both sides of the equation by 200. And we'll get 200 times the tangent of 20 degrees, which we can put that in our calculator, and we get approximately 72.79 meters. And since it tells us to round to the nearest meter, we'll call that 73 meters. So the next example, so we have a trail that leads up from the Alpine Hotel at an elevation of 8,000 feet to a scenic overlook, which has an elevation of 11,100 feet. And we know the length of the trail is 14,100 feet, and we want to find what is the inclination, or sometimes called the grade, of the trail. Okay, and what that means is we want to find this angle, right? Okay, so we're given the length of this trail, which again is this piece right here. Okay, and we know the total elevation. So we're dealing, if you think about this in terms of right triangles, this would be our hypotenuse, and this would be our opposite side. Okay, so we've got opposite and hypotenuse. So we want to use the sine function. Okay, so we have sine of B, okay, sine of angle B is equal to the opposite side, which is just 3,100 feet, over the hypotenuse, which is 14,100. And so we know if the sine of B is equal to that ratio, then by taking the inverse sine, we know that angle B will be equal to the inverse sine of that ratio. Okay, so remember, when you are looking for an angle measure, you're going to use an inverse trig function, because the inverse trig function says, hey, If you tell me what the ratio is, I'll tell you what that angle is. And when we put this in the calculator, we should get about 12.7 degrees. Okay. And again, make sure you're in degree mode and not radian mode. Okay, so the incline is about 12.7 degrees.